This video is a wrap-up of the exploration from 9.3. The learning targets for this were to convert between polar and rectangular coordinates. In one of the classes today, we got further than in the other one. I want to make sure that it is clear and that we point out something that you need to be very careful of that you want to pay attention to. So we have the following relationships that we wrote down in our exploration today. And one is that on our unit circle, the x-coordinate can be obtained by the radius, which in our unit circle, the length of the radius was 1 times the cosine of the angle, or radius times cosine of theta. And the y-coordinate can be obtained by r times the sine of theta. So in this case, if we had a polar coordinate, let's say we had a radius of 3, and we were looking at the angle being pi over 4, to find this is polar, to convert this coordinate to rectangular, we would get our x-coordinate by doing 3 times cosine of pi over 4, and our y-coordinate by doing 3 times sine of pi over 4. And if it were not an angle in unit circle, we would just use our calculator, make sure that our calculator was in radian mode. But since it is in the unit circle, this will be 3 times square root of 2 over 2. It'll be 3 square roots of 2 over 2, 3 square roots of 2 over 2. The decimal approximations for that, 3 square root of 2 divided by 2 is roughly 2.12. Let's check on our calculator to see that this is the case. So we have, I'm going to make sure that I am in radian mode, and I'm going to do 3 times cosine of pi over 4, and 3 times sine of pi over 4. We already know that that's going to give us the same thing for pi over 4, and sure enough, it is the same decimal approximation. But this is the exact answer if they ask for exact. If they don't ask for exact or it's not on the unit circle, then we can get the approximate answer. When we go to graph on a graph paper, we would want to graph the approximate. So this is the relationship that we used to convert from polar to rectangular. From polar to rectangular. And that's how that relationship works. Now we should also pay attention to where this point is located, just to make certain that it's going to give us the right ordered pairs. It should in these cases when we're going from polar to rectangular. We have to be more careful when we're going from rectangular to polar. So this is pi over 4 and it's a positive radius, so I know that this is in quadrant 1. Positive 2.2 right up 2.2 up 2.2 is also in quadrant 1. So I know that this point and this point are at least in the same quadrant. Hopefully I did the right calculation to get the right decimal value. Now we're also going to look at the other relationships that we made a note of today. And that was that when we have our unit circle and we have a terminal ray, there is an x-coordinate and a y-coordinate to that terminal ray, and a radius. It doesn't have to be 1. And we said, well, that means that the radius squared is x squared plus y squared, which is true. And we also said that the angle had a relationship to x and y. Since y is the opposite and this is the adjacent, the tangent of theta is equal to y over x, or theta is equal to tangent inverse of y over x. These two relationships are what we need to use when we're converting from rectangular to polar, because we'll only have an xy coordinate, such as -3, 4. I know we did one case of positives in class. So this, I want to pay attention to where this point is. We're going to convert this to polar. To find the radius, that's pretty easy. -3 squared plus 4 squared equals the radius squared. That's going to be 9 and 16, which is 25. which means our radius is 5 or negative 5, which is still going to give us the same circle. We're going to go with the positive. The radius is 5. So we put that right up here. That's great. Now we have to find the angle. Well, we have the angle relationship right here. Theta equals tangent inverse of y over x. We have to be really careful, though, because right now I know that negative 3, 4, in terms of the coordinate plane, is left 3, up 4. This is in quadrant 2. But we're going to be doing tangent inverse. Tangent inverse, if you remember from our unit circle, because we had to restrict the domain of tangent in order for its inverse to be a function, tangent inverse will only give us an output from negative pi over 2 going down to positive pi over 2. But that's not quadrant 2. This is the piece where we have to be very careful. We have to get ourselves to quadrant 2. We'll talk more about that in a second. Theta equals tangent inverse of y over x, 4 over negative 3. I'm going to do this in degrees. I'm going to do my polar coordinate in degrees. Sometimes it'll ask in terms of radians, and that's fine. But since I'm going to do degrees, I'm going to change it to degrees. So I'm going to do tangent inverse of 4 over negative 3, and I get that theta is negative 53 degrees, which would put it back around here in quadrant 4. But we know that it's not in quadrant 4 because the actual point negative 3, 4 was in quadrant 2. Well, how many units away are these? Well, if we're in radians, they'd be pi units away. But since we're in degrees, they are 180 degrees away. So to this, we have to add 180 degrees to get back to quadrant 2. So if I add 180 to that, it tells me that the angle is 126 degrees, or roughly 127 degrees. So my polar coordinate is 5, 127. That's a pretty good approximation of the location of negative 3, 4. Those would show up right about here. Am I always going to add 180? No. If the polar coordinate is where it's supposed to be, then I will probably add, if it's in quadrant 4 where it's supposed to be, I'll probably just add 360 or 2 pi to it to get the positive value between 0 and 2 pi. Let's look at an example. Let's say we were given the point 2, negative 10. We know that in the rectangular coordinate system, this point is somewhere, well, actually it'd be somewhere down here, 2, negative 10. So we are in quadrant 4. That's great. When we do tangent inverse, we'll get there. So we have r squared equals x squared plus y squared. So that's 104. R is the square root of 104. So right now my polar coordinate, I'll have a decimal approximation or an exact value of the square root of 104. To find theta, though, I have to do tangent inverse of the y over the x. That's tangent inverse of negative 5. When I do this in degree mode, it once again gives me a negative 78, actually negative 79 degrees to the nearest degree. Negative 79 degrees. So yay, that's also, right, I'm paying attention. This is in quadrant 4. Hey, that's quadrant 4. I'm happy. Except it has to be a number between 0 and 360 degrees. Or if we're in radians, 0 and 2 pi. I don't want to add pi because then it would put it in quadrant 2. So if I add 2 pi if it's in radians, or rather, since we're in degrees, 360 degrees, I'll get my answer, 281 degrees. We've converted a rectangular coordinate pair xy to a polar coordinate pair r theta. So once again, we use these equations as a relationship to help us find the x and y coordinate when we're given a polar coordinate, and we use these relationships to find r and theta when we're given a rectangular coordinate.